Good afternoon, dear students. On the last practical lesson, we were solving tasks related to linear spaces, and today we are continuing studying linear algebra. Our today topic is linear operators, and of course, I have a question to the group. Who can answer what does a linear operator mean? And by the way, what is the operator? No questions. Yeah. So nobody remembers. Okay, I will remind it for you because this topic is complicated. Linear algebra in general. Okay. So let me share my screen. By the way, the operator is the mapping that transforms one element into each other. So it can be any element. Function is so f depending on x, by the way, is uh, partial case of the operator, which maps uh, one number to each other. But linear operators can, so just operators can, they work with different elements, so vectors or maybe functions and other elements such as matrices and so on. Okay, so what about a linear operator? Let's remember this definition. So a linear operator is the operator that works in a linear space, and it matches. So it looks like this. So so operator A, and this is the element. And so which properties it matches? So first of all, that if x belongs any linear space, it means that the so that the element. So if we apply our so the operator to our element, it also belongs this linear space. And also linear operator has the following uh, properties. First of all, it is homogeneous. It means that we can move alpha out of brackets. Alpha is so it's just a real number, any real number, so scalar. Also, it's additive. So if we apply a linear operator to the sum of elements, it will be equal to, so it will be the same as we apply separately to two or more elements, and their sum will be the result. So it will be equal. So, but generally, we can unite these rules, these properties, so like in this way. So something like that. Okay, any questions for now about theory? Okay, it seems that no questions for now. So first of all, let's solve the first task. Let me firstly zoom in. Now you also have a solution for this task, but let we solve it in our own. So just let's try. Maybe anyone can answer how to solve. So we have the operator A in the linear space L, which works on this rule. So it adds any vector to our initial vector. So we need to check if this operator is linear. How to solve? Any ideas? Okay, as I see no ideas, you need to see first of all how to solve it. Okay, so first of all, let's check if it is homogeneous. So A alpha X, if we do that, and how it will work. So it equals so alpha multiplied by x plus alpha multiplied by a. And actually it equals so alpha multiplied by ax. So we can we can move this scalar multiplier out of the operator. But that's not enough. Now let's check additivity. So we'll apply it to two different elements, x and y. So what can we see? So it equals x plus y. Let's put brackets here. And plus a. And now let's apply this operator to elements separately. So for x, here is it. And for y, actually the same recording, the same form, but we just replace y, x with y. And now let's add these operators separately. And it will be equal x plus a plus y plus a. And then, of course, we will simplify it. X plus y plus 2a. So, what can we say about this? So, if equal or not? So, operator of the sum and the sum of operators. Equal or not? So, what can you say about it? So, who want to be the first? Mykola?
I think they are equal.
Are you sure? Look attentively at this and at this. And so what can you see?
Plus, I don't know.
So this and this. So you don't see any differences, right? Okay, and who thinks that they are different? Okay, yeah, I see a lot of hands. Okay, Stanislav? Yeah.
They're not equal because in the second one we have two A's.
Yes, of course, that's correct. So A and 2A. So here we just add A to this sum, and here we add to it this A vector to each element. And when we add elements with the so on which we apply this operator separately, we so have 2A. So it means that not equal. And what does it mean? Is the operator A linear or not? Okay, Daniel?
Sorry, can you please repeat twicely why we start solving these two different equations?
Not actually equations. So what is the property of linear operator? So we were checking this property. So if we apply if we apply the operator to the sum of elements, it must be equal to the sum of applied operators to each element separately. And we need to check if mhm. Okay, my annotations went away. So these expressions must be equal. And what we see here, if we apply to the sum of x and y, so we see the following result. So we just add a to this sum. If we apply separately to x and to y, so we add a to x and we add a to y. Then we need to add these two equations, as you say. We need to verify if this equals this. And as we see, they are not equal. So have I answered your question?
Yes, thanks.
So is the operator linear?
No,
No, it's not linear because it doesn't match this rule. Yeah. Okay. Maybe any questions about this exercise? Okay, if no questions, let's continue. So our next task will be almost the same, but we will have other form of the operator. B will be for your home task. So now we will raise it. So we need also check if this operator is linear. So actually we need to do the same that we did in the previous exercise. But here we have another form of the operator. So if we apply operator A to x, so it transforms our vector x1, x2, x3 to another view. So first coordinate is not changed. The second coordinate looks like this, and the third like this. Now let's check the first so homogeneity property, and it looks like the following. writing everything in details for better understanding. And we can move alpha out of brackets. I will just copy and paste it. So it equals alpha AX. And now let's check the sum. So it will be look in the next way. So x1 plus y1, the first coordinate. Here x1 plus y1 minus x2 plus y2. So I just substitute x with this sum. So x1 with x1 plus y1, x2 with x2 plus y2, and x3 with x3 plus y3. Okay, what to do now? Now I will regroup these elements. So separately x, separately y. And so it will be easier for us to see if uh, this operator is linear or not. So x together with x. So x1 minus x2 plus x3. So plus, so y1 minus y2 and minus y3 and plus y3. Yeah, identically to signs, of course. Then the third coordinate, so 4x1 minus x2. Plus 4y1 minus y2. And now we can transform it, so we can write it as a sum of two vectors. So x1, and here x1 minus x2 plus x3. And by the way, it will be quicker. Y1 And of course, not to forget set comma here. So what do you see here? How can we substitute these vectors that we have here? Any ideas how to simplify? So just what do you see here and here?
We can write the first part as operator A from X,
Yes,
and the second one is an operator A from Y.
A from Y, yeah, that's correct. So that's actually what we have. So A applied on sum of these elements equals the sum of operators applied to these elements separately. So what does it mean if so the operator A is linear or not?
It's linear.
Yeah, it's linear. Okay, maybe any questions about this task?
No questions.
Okay. Here you have a solution as well for this task for part B also, but it will be better to check it in your own and then check the solution. Let's move next. Task 3. So we have so we have two bases, E1, E2, and E1 prime, E2 prime. And we have the matrix of a linear operator. Yeah, so linear operator can be written as the matrix, the equivalent form. So if we write it in vector form, so just for your understanding, in current task. So AX will look like the next. So it equals x1 minus 2x2 and x1 plus 3x2. So that's how it looks like. And by the way, so operator operator A from this task, operator B as well, of course, as well. So it can be also written as the matrix form, but we will also check it in other tasks. So we will have this such task. So it's explicit form, and it is the matrix form here. But so it is more useful for us to write it as a matrix. But these forms are equivalent. So, what do we have to do? So we need to find, so this is matrix of operator A in bases E1, E2. We need to find a matrix of linear operator A, it will be A prime, in other bases. So E1 prime, E2 prime. So we have the rule for these vectors. And by the way, how to find the matrix of the linear operator in other bases? Any ideas? Do you remember how to do it? So it is almost the same, so similar to finding vector coordinates in other bases. What do we have to apply? What to use? Maxim?
If I'm not mistaken, we need to multiply the matrix of an operator A by a matrix in the basis A prime.
We need to find A prime, and how to find it?
E prime, E prime.
E prime.
Yeah, we need to substitute the coordinates from these factors in the columns and multiply this matrix by matrix A.
You want to you're talking about transition matrix, right? From one basis to another, correct?
Yes, yes.
And how do we multiply? So what? So just by the order. So what goes first? I will remind you that a transition matrix is usually marked as T.
Firstly, matrix A, and then transition matrix.
Actually not. So firstly, so it looks like that. So we multiply matrix A by matrix T from the left, inverse T from the left, and by normal T on the right. And first of all, we need to build a transition matrix. So it looks in the next way. So we just set vectors as columns for transition matrix. And now we have to find the inverted matrix. So T11 equals -4, T12 equals 1, T21 equals -3, and T22 equals 1. And now let's calculate the determinant of matrix T. So -4 plus 3, it equals -1. Okay, so no fractions, I like it. When we don't have any fractions. And how T -1 looks. So don't forget minus in front of the matrix. And now let's write, so don't forget that it must be transposed. So -4, then -3, and 1, and 1. And now for multiply by -1. But let me better check if everything matches. Yeah, so that's correct. Everything. All right. So now let's multiply our matrices. So A prime equals, so this matrix. One, 1, -2, 3. And multiply with the initial T matrix. So firstly, I will multiply these first two matrices. So now let's remember how to multiply. So 4 plus 4 by 1, 4. Oh, okay, but let's write in details. Then here 4, why it's not drawing? 4 by -2 plus 3 by 3. And then -1, -1 actually. And here 2 minus 3. And don't lose this matrix. So here 7 minus 2. Oh, maybe I have to replace battery in my mouse. So -8 plus 6 minus 2 and -1 multiplied by this matrix. And now we will multiply them as well. Seven by 3 plus 2 by 4. -2 plus 1 -2 by 3 plus 4. And what we have now? 7 plus 2, 9. 21 plus 8, 29. -1. So -6 plus 4, -2. And now let's check if I'm not mistaken. So something went wrong. Okay. So 7. Yeah, so something went wrong even earlier. So 4, 3 minus 1, 1. 1 minus 2, 1, 3. Okay. So 7, correct. And then 4 by -2, 9. So 3 by 3, yeah. So, So what we actually have? So here 1 must be, and nobody told me that I was calculating wrong. So -2, -1. So these cells are correct. And then, of course, so we need to recalculate. So 21 minus 4. So 21 minus 4. -17. So 9, 17 minus 1 minus 2. 6, 17. Okay, let's go recalculate it as well. So 7 minus 1. Why I was calculating in such a way? It's interesting. That's a riddle. But nevertheless, we have the final result. So yeah, now everything is correct. And what was actually the final task? Yeah, so we had to find the matrix of operator A in other bases. Do you have any questions about this task? Or no questions?
No.
Can you please scroll up?
Yeah.
Now, why do we have -1 at the first appearance of t?
Do you mean this?
No. Те, що справа.
Ось це?
Мгм.
So we are building inverted matrix. So we find cofactors. So you are asking about signs, right?
Yeah.
So, okay. Students also forget very often how to build algebraic complement or cofactor. So the formula is -1 in power of I plus j.
Ні, я трохи не про це.
Ні, окей.
Там якась... Можете показати матрицю початкову взагалі, яку нам давали?
Матриця А.
Ага.
No, we don't need use it for for transition matrix. Матриця лінійного оператора це не матриця переходу.
Мгм.
So we build matrix T using these vectors in a new basis. Матриця переходу будується на векторах в новому базисі. Вектори є стовпцями цієї матриці.
Все, я зрозумів.
Okay, more questions? So actually the same that we were doing on the previous lesson, yeah, but of course it was quite long ago, a week or even 2 weeks ago. So it was a long break, or either with your group or with the second, but yeah. Okay, so now I'll erase my drawings here, and we will move to the next task. Very interesting task. So we need to find a product of two operators. And I have a question. What does the product of linear operators means? So just any operators, even not necessary it must be linear. Daniil?
Multiply numbers.
Actually, it's not. So it's not the product in. So as we usually understand. So not. So as not as we understand. So we just multiply one number by each other and so on. It means that we firstly we apply operator A and then we apply operator B. So, what does it equal? Oh no! In this case, first we can write some brackets. Put brackets here. So we multiply. So we apply operator B to x. And then we apply operator A to this element. Or I can even expand it. So let bx equal y. And so abx equals a apply to y. So we just in particular order we apply operators. So what does it mean? So not the product in our usual understanding. So it doesn't equal so this. So it is not equal products of operators. Absolutely. So it's a different thing. Okay, any ideas how to solve it? No hands. Maybe we can rewrite our operators. So it's like a spoiler. That's a tip. Rewrite to another form. Yeah, so the idea will be to rewrite our operators to matrix forms. So matrix for operator A will have the next form. So how to rewrite from this form? So these elements will be rows. Yeah, Daniil, questions?
I think that first row will be x1 plus x2, second row x2 plus x3, and third x1 plus x3 of matrix A.
Yeah, that's correct. But of course, we won't write x, we will write coefficients. So 1, 1, and 0. But yeah, you were right. So here, so 0x1, so 0, 1, 1. And here, 1, 0, 1. So this is the matrix for operator A. And matrix for operator B. So idea is the same. So here 0, 1, 1. Here 1, 0, 1. So we write just coefficients. So each cell equals coefficient before coefficient for x. And here 1, 1, 0. And then, so we need to find ABX. How to find it? Actually, we need to multiply AB, matrix A by matrix B, and then by matrix X. So it will look like this. Yeah, so yeah, here it is similar to the product. Yeah, so if we multiply matrices, so if we want to find the product of the operators, we must multiply their matrices of the operator. So now let's multiply A and B. Okay. Yeah, I know you like multiplying matrices with dimension 3 by 3, but this is the only way to solve the task. So for this the first cell, I will divide a little bit, just not to get confused from this matrix. So 1 by 0, 1 by 1, and so 1 by, so 0 plus 1 plus 0, 1. Okay. And then So 1. Why my annotations don't work? Okay, so 1 by 1 plus 1 by 0 plus 0 by 1. Okay, so 1 here as well. Then 1 plus 1 plus 0, 2. Okay. Then 0 plus 1 plus 1, 2. 0 plus 0 plus 1. 0 plus 1 plus 0, 1. 0 plus 0 plus 1, 1. And 1 plus 0 plus 1, 2. 1 plus 0 plus 0, 1. Okay, so it is the matrix of operators product. So now we'll write we'll write it in more convenient form. And let's better check it. So with so 1 1 2 2 1 1 1 2 1. Okay, so correct. And now I'll clear my Zoom drawings. Now let's multiply x by this matrix. We also can, by the way, mark it as C. We also can so define operator C, which is a product of operators A and B. Why not? We can do it. Okay. So multiplying x by this matrix. No. We multiply matrix by x. And let's look how our so which coordinates of the vector. So 1 1 1. What we have. And it will be just a vector column. So 1 plus 1 plus 2, 4. And then 2 plus 1 plus 1, 4. 1 plus 2 plus 1, 4 as well. So here is a y that basically it equals a by b by x. So if we apply operators a and b in such a sequence, of course BA doesn't equal AB. We can conclude it from the matrix not commutativity property.
Sorry, but why we multiply by y1 1 1 matrix?
Because here is our element x.
Okay, understand this.
Or maybe I'm missing something, by the way. So AB, so 1. No. So incorrect recording. So just tell you not truth. So we found the matrix, but now we so how to apply it? So it's not we don't have to multiply by the vector column. So how it basically look like? So our C operator looks like that. So we will write it in explicit way. So just transform from the matrix. So it is the product. And how to write it in an explicit way, I just take these rows and write here as vectors as the coordinate of the vector. And then 2x1 plus x2 plus x3. Then x1 plus 2x2 plus x3. Yeah, so not usual product. Okay, any questions about this task? It seems that you have no questions. Okay, now let's have a break for 5 minutes and then we will continue.
Can you check my question, please?
Yeah. Okay, let's continue. Stanislav, I checked your variant number 17, so if not mistaken. So actually you you made a mistake. So everything is okay for me. The determinant is non-zero, so check minuses. So especially triangles parallel to the secondary diagonal.
All right, thank you.
Okay. So let's continue. Let me share my screen. So task 4 is done. Yeah, more questions? I just saw somebody's hand. Okay. Task 5, it's actually almost the same, but you need to do more actions. So we have to find a product of AB and then BA, and after that to subtract these operators, and then do that we did before. So now let's move to the next task, task number 6. So I won't say that it is something new, but let's practice. As well, transition to other bases. It will be nice practice. Oh, okay. Let's go with this. First of all, yeah, because it needs more attention. This task. So what we have? Operator A in basis E1, E2, and operator B in basis E1 prime, E2 prime. So one operator is defined in one basis and other operator is defined in other basis. And the first part A is to find sum of operators A plus B in basis E1 prime, E2 prime. So how to solve? Any ideas? Raise your hands. Maxim?
So firstly, we need to find the matrix A in the prime basis and then add it to the matrix B.
Yeah, and in section C, how to solve this?
Everything remains the same, but we need to multiply. No, we need to reverse the matrix B in the initial basis and then multiply them.
Actually, or maybe let's better mark it in this way. So, yeah, we need to find matrix B in basis E1, E2, and then A multiplied by B. So A doesn't change in this part. So now let's find the first. So let's solve A, and then we will see how much time do we have. So matrix T. First of all, we need to find a transition matrix. So 1, minus 1, 1, 1. And of course, cofactors. T1, 2, now 1, T 2, 1 equals -1, and T 2, 2 equals 1. And the determinant of matrix T, so 1 plus 1 equals 2. So let's write our inverse matrix T. One second, multiplied by 1, 1 minus 1, 1. And now let's find A prime. First of all, we need to so let's write the formula first of all, and then we will substitute matrices that we need. Okay. Three, 5, 1, 2. So 1, 1. So 3 minus 5 minus 2. Then 1 minus 2. It's -1. 3 plus 5, 8. And then 1 plus 2, 3. Yeah, for this matrix, brackets look like determinant. -2 plus 1. It's -1. Then -2 minus 1, -3. 8 minus 3, 5. 8 plus 3, 11. And now let's multiply by 1 second, so -0.5. Let's write in this way. Decimal. And now let's check with the example. Yeah, so matrix C. So A prime, and then we need also to add these matrices. Of course, not to forget it. So A prime plus B equals 1, 2 minus 2, 3. So 0.5, 0.5, 0.5, and 8.5. So here is the matrix of this operator. Yeah, and by the way, so we want to solve section B now, but I have a question for you. So how to so we have a transition matrix from basis A to basis so from this basis, initial basis E1 E2 to this basis prime, we have a transition matrix already, and we have inverse transition matrix. How to transform matrix B for initial basis? So do we need to find some extra matrices, or we already have what we need?
We just need to put except of AB.
Sorry?
We already have data, but we need to put except of AB matrix.
Yeah, but we need something more. Yeah, so actually, so if we need to move to basis prime, so this is so we need also to replace so to change to swap these matrices. So if we need to go from basis so initial basis to basis prime, so it means that B equals T by B prime. So if we mark it as prime, T by B prime by T inverted. So what does it mean actually? Yeah, but your thoughts were correct. So just corrected everything. Any questions about this task?
Can you repeat, please, why we need to swap the by places? I understand that it doesn't change calculation, but why we need?
So if we need to move from basis A to so from initial basis to basis prime, we need to so first we multiply matrix in initial so matrix A by inverted matrix T, and then by real so by initial matrix T. And we for operator B, for matrix B, we need to go to initial basis, from prime to initial. That's why in this case we swap. So T is transition matrix from E to E prime, and T minus 1 inverted, so from E prime to E. So that it doesn't, so it means that you already have matrix, transition matrix, and you don't have to find it once more. So have I answered your question?
Yes,
Mhm. Okay, more questions about this task? Okay, so let's move next. Let's go next. Mhm. Okay, by the way, what do you remember about matrix image, kernel, rank, defect? Okay, you don't remember. Maybe anybody, somebody else, because I want to hear everyone, but so just for more various answers. Okay, Daniil.
For vectors x belongs to L, where L is linear space, where operator A multiplied by vector x equals 0. It's called kernel of linear operator. Image is called when set of vectors y equal to operator A multiplied by x vector, where x belongs to linear space.
Yeah, so image of the operator, yeah, correct. So it's just the element that we get on the exit. Okay, and what about rank, defect?
Me too, yes.
If of course I want to hear somebody else, so it would be nice if somebody else answers. But everyone are shy, so okay. Your turn.
Defect is when operator A dimensionality of kernel it's called defect A.
Yeah, so it's dimension of kernel, yeah.
And dimensional of image is called rank.
Yeah, correct. Okay. So now let's start on finding all these things. So first of all, I will write a operator A in matrix form. So 2 minus 1 minus 1, then 1 minus 2 and 1. 1, 1 minus 2. So we need to find first of all kernel. Let's do it. So how to do it? We just need to solve this. Solve the homogeneous system of equations. So actually, we have the definition of kernel in a matrix form. So we need to find x1, x2, x3. So let's start with our favorite Gaussian method and check. So I will move the first row 1, 1, 2 at the top. So let's swap lines, rows.
After this operation, do we need to change a sign?
No, we just swap equations. equation places. So if you just swap equations order in in system of linear equations, or even non-linear doesn't matter, nothing changes. So we don't calculate the determinant now. It is important for determinant. Okay. So this row without changes. That's not basically what I wanted to do. So here we have zeros. Okay, then. Don't forget about your safety. So -1 -2, it's -3, then -2 +4, 3. So 0, -2 -1, and 1 + 3. Okay. And basically what we have. So we'll just reduce the matrix. And of course, divide this row by 3. Now we'll write shortened form. So the rank of the system is 2. So basis variable is x1, and other variables x2 and x3, they're free variables.
Can I ask a question?
Yeah.
Why did we change the signs in the second row? So it was -3, 3, and we got 1, -1.
For me, it looks more convenient. So just to multiply by or divide by -1. So I divided by -3, basically. It's more convenient for me. If you like -1 here and 1 here, it doesn't matter, nothing changes.
Okay.
So x1, no, so here it's x2. So x1 equals -x2 plus 2x3. And by the way, x2 equals x3. So if we mark x2 and x3 as c, like just a constant, we will have that x1 equals c. So the kernel of operator A is so looks like that. C. By the way, yeah. C and aren't I so confusing anything? So 1. Oh no. Let me check. So 0, so x2 equals x3. C, C, and here is C as well. So it's a kernel. And actually, the basis of the kernel is the fundamental solution system. So, as we know the kernel, what can we also write? So, which value that we had to find here? Okay, so as we know kernel, we can find defect. And what does defect will be equal here? So what is the dimension of kernel A?
One.
Yeah. So defect of A. So yeah, it equals dimension of kernel. And it equals 1. Yeah. Okay. But also it can be calculated in another way. So it is so n minus rank of matrix A, and matrix A has rank 2. So other way to calculate. And what can you tell about the image of the operator?
It equals to the rank of the matrix.
So a rank of the operator, of the linear operator, yeah, it basically equals a rank of the matrix A. So this A equals this A. So yeah, so the rank of the operator is equal to matrix, which sets this operator. Okay, any questions to this task? Maybe more questions about about previous tasks, about your homework, individual tasks.
No questions at the moment.
So currently our lesson is finishing. We have no time for other stuff. Okay, Maxim?
I wanted to ask about the test that we will perform soon concerning linear algebra. And I want to know what will it look like.
What do you mean? So individual task, right? Or what?
No. Test after each topic that we have.
Okay, so on DL, as I understand, you mean this one, right?
Yes.
Well, so I won't tell you what this test about because I haven't seen its structure. But you can ask more Svetlana Mykolaievna about it. So basically, it will about all tasks that you had before and how it works. So on DL, you have some time to solve. And when the time is up, the testing is finished, or you can finish it earlier. Like, so you were passing an NMT, by the way, so it looks like that. The procedure is the similar. So so your mark will be calculated automatically.
Okay, and about the restriction of the time, do you know something about that? So we need to do this test like strictly from, for instance, 11:30 to 12 o'clock. When we have
Oh,
errors.
you. By the way, could you show me how does it look like on your side? So I see it.
We don't see yet
Ah.
this test. Yes.
Okay, so it depends on the test. So how many tasks are there? So ask Svetlana Mykolaievna about it because I guess I won't check this test. It will be checked automatically. So I'm sure.
Okay.
Okay. More questions?
Yeah, so we will have this test after the 10th practical lesson, yeah?
Sorry, could you
We
repeat?
will have this test after the 10th practical lesson.
I don't know when are you going to have it. Yeah, so definitely you will first of all finish this module, so linear and vector algebra. Of course, not before, but after. Of course, when you have all practical lessons. Sure. So you have enough time to for review for now. So yeah, look through tasks that were before and attentively solve that you have now. So you have enough material for the practice. Have I answered your question?
Yes.
Okay. What else? Well, it seems that no questions, so we are finishing our lesson. Have a nice day. Stay safety. Goodbye. Thank you for your attention.
Thank you.
Goodbye.
Goodbye.